In this lesson, you will learn how to solve systems of linear equations graphically. So these graphs below show the three different possible graphs that you could get by solving system of equations. The first one is when the two graphs intersect, and when they intersect at a single point, there is one solution. And for this graph, the solution is the point 1, 3. Sometimes two lines are parallel to each other, and since the lines never cross, then there is no solution. If you look closely at the third graph, you'll see that the red line is overlapping the black line. Since they are overlapping, that means they have every point in common, so therefore this has infinitely many solutions. For questions 1 and 2, we want to determine whether the ordered pair is a solution to the system of linear equations. And we're given the point 2, 4. 2 is our x and 4 is our y. So we want to take the two equations, 2x plus y equals 8 and y minus x equals 2, and substitute 2 in for x, 4 in for y. And when I do that in the first equation, I get 4 plus 4 equals 8. And since both sides are equal to 8, that means the point 2, 4 is a solution to 2x plus y equals 8. If I do the same thing in the second equation, I still substitute 4 in for y, 2 in for x, and when I solve the left side, since I have the same number on both sides, the answer is yes, that the point 2, 4 is a solution to the two equations. For number 2, we'll do the same thing. X is 2 and y is 7. So if we take the first line, 3x plus y equals 13, and substitute 2 in for x and 7 in for y, and solve, 6 plus 7 is 13. And since we get the same number on both sides, then 2, 7 is a solution in the first equation. But in order for the final answer to be yes, it also has to work in the second equation. So I take 2, substitute it in for x, and 7, substitute it in for y, and I get 2 plus 42 equals negative 7, and the final step is 44 equals negative 7, which is not true. It has to work in both. So 2, 7 is not a solution. For questions 3 through 6, we'll solve the system of linear equations graphically. So let's take our first line of y equals negative 2x plus 3. This line is already in slope-intercept form. So if I match it up with y equals mx plus b, my slope is equal to negative 2, and to write that as a fraction, we write negative 2 over 1. We always move to the right with the denominator, but depending on the sign of the numerator tells us whether to move up or down. Since 2 is negative, we move down. B is equal to 3, so our y-intercept is the point 0, 3. So we start at the point 0, 3, and from this point we go down 2, right 1. You can plot as many points as you like. The more points you have, the more accurate your line will be. Or you can use a ruler and connect the points, extend the line, and place arrows at the end. Then in black, the second line is y equals 1/2 x plus 3. And if I match this up with y equals mx plus b, I see that my slope is 1/2. I always move to the right with the denominator, and since the numerator is now positive, I move up, and my b is 3, so as a point, it's 0, 3. So I start at 0, 3, which is the same point that I started with on the other line, but now I move up 1, right 2. And again, you can graph as many points as you'd like. Connect the points as best you can. And there's my second line. And they intersect at the point 0, 3. So the answer is the point where they intersect at, which is 0, 3. For number 4, the directions are the same, but this time 4x plus 3y equals 27 is not in slope-intercept form. So I have to solve for y. And I start by subtracting 4x from both sides so that I get 3y equals negative 4x plus 27. Divide everything by 3 so that in slope-intercept form we have negative 4/3 x plus 9. And if I match this up with y equals mx plus b, the slope is equal to negative 4/3, which means down 4 and right 3. Always move to the right with the denominator, and the sign of the numerator tells us whether to move up or down. And then b is the point 0, 9. So if I go to my graph, I start at the point 0, 9, and I move down 4, right 3. I connect the points. And now I take the second line, negative 2x plus y equals negative 1. And to solve for y, I add 2x to both sides. And in slope-intercept form, I have y equals 2x minus 1. So if I match this up with y equals mx plus b, my slope is equal to 2 over 1. So I move up 2, right 1, and the y-intercept is negative 1. So as a point, it's 0, negative 1. And I put my first point at the y-intercept, and I move up 2, right 1. And the point where they cross at is x equals 3, y equals 5. So the solution is the point 3, 5. For number 5, I again start with my first equation and put it in slope-intercept form. And when you're putting it in slope-intercept form, you start by moving the x over to the other side of the equation by either adding or subtracting. So we have 2y equals 4x minus 2. I can't combine the 4x and the negative 2 because they're not like terms, and I always like to write the x term first so that it's in y equals mx plus b form at the end. Then I divide everything by 2, and I get y equals 2x minus 1. So my slope is 2 over 1, the number in front of the x, so that means up 2 and right 1. And my b is negative 1, so as a point, it's 0, negative 1. So I start at 0, negative 1, and I move up 2, right 1. And I take my second line, and I start by moving the 2x over to the other side by subtracting, and I'm left with negative y equals negative 2x plus 1, and we have to have this as y equals, so we have to divide every term by negative 1. So when I divide everything by negative 1, I'm left with y equals 2x minus 1, which is the same equation that I got with my first one. So since it's the same equation, that means that the slope is also 2 over 1, up 2, right 1, and that my y-intercept is 0, negative 1. So when I graph this, it's actually going to be the same line. So since the lines are overlapping, it doesn't have a unique solution, meaning only one solution. It has infinitely many solutions. For number 6, the first equation is 4x minus 5y equals 10. And I start by moving the 4x over to the right so that I have negative 5y equals negative 4x plus 10. And I divide each of the terms by y's coefficient, which is negative 5. And when I divide each term by negative 5, I'm left with y equals positive 4/5 x. The negatives cancel, and then 10 divided by negative 5 is minus 2. So my slope is 4 over 5, up 4, right 5, and my y-intercept is the point 0, negative 2. So I go to my graph. 0, negative 2 is here. My slope is up 4, and then right 5. I connect my points. And I move on to my next line. I add 8x as my first step, and I have 10y equals 8x plus 30. I divide everything by 10, and I have y equals 8 over 10 reduces to 4/5, and 30 over 10 is just 3. So I have a slope of 4/5 again, so up 4, right 5, and I have a y-intercept of 3, so it's the point 0, 3. So notice how both lines have a slope of 4/5, but their y-intercepts are different. So when two lines have the same slope but a different y-intercept, it means the lines will be parallel. So when we graph that, we start at the y-intercept of 0, 3, and let's just move this up a little bit. Up 4, right 5, we're a little bit off the graph, but up 4 is right about here, and right 5 is right about here. When we connect the points, our lines definitely appear parallel, and parallel lines never cross, so the answer is no solution.